All right, so we're working through some of our 1.3 homework examples, and we're on number something similar to your number 13, where we're foiling. When you have a parenthesis times a parenthesis, two terms times two terms, that's usually the FOIL method. So we can FOIL even with these imaginary complex numbers. We'll do the first times the first. 9 times 6 is 54. The outer times outer, a 9 times I, we'll just call that 9i. Inner times inner, negative times a positive, so we make that negative 42, and it also has an I on that. Okay, then last times last, a negative 7i and a positive I is negative 7. You kind of multiply the number parts. Negative 7 times the 1 there, and then I times I makes I squared. Now, something special when you hit an I squared is I squareds are always equivalent to negative 1, and we're expected to reduce that. So we're multiplying really between those. So negative 7 times negative 1 will make that just a big old positive 7. So the I just gets reduced out of it. So you always need to do that when you hit I squared, and that'll happen a lot when you do the imaginaries and the foiling. You'll hit an I squared that needs reduced. It basically just changes the sign of your term because that's a negative 1 times onto that. So you can just know whatever sign that is, it'll be the opposite, and then the I will be gone. So we've got a 54 and a 7. Let's see, that's 61. Then 9i and minus 42i is negative 33i. And it does need to be an A plus BI order, which means the real part, then the imaginary part. Okay, another example 14. We're foiling first. First is 36. Outer is positive 6i. And the inner, we've got a negative times a positive, so it's negative 48i. Then last times last, a negative 8i times a positive 1i is negative 8i squared. As above, we notice that changes that to a positive 8 altogether. So 36 and 8 is 44. Positive 6i and minus 40i will be negative 42i. An answer. Okay, jumping down to 10, we need to be careful with this because we're square binomial. A squaring pattern you can use, but it's not just square that and square that. There is a middle term involved, and you can see it more readily if you got this as writing it twice. You know, because it's squared, it's the same thing itself, and that's back to the FOIL method. So I'm just going to do it with the FOIL method. So first is 36. Outer is minus 24i. Inner is another minus 24i. And then last times last, the signs are alike, so it would be positive 16i squared. So the pattern for squaring a binomial, if you haven't used that in a while, is you square the first, and it is the square of the last. The square of the first, the square of the last, but there's also these middle terms, and they double. You multiply these two terms together, so that's the negative 24i, and then there's two of them. So the shortcut, if you want to use that, is square the first, the square of the last, then times these together and double for the middle. So reducing this, that'll change to negative 16. So 36 minus 16 is 20. Minus 24i and minus 24i is minus 48i. And that's your final answer to that. Now you might be able to do these on your calculator, and that's just fine. You do need to be in imaginary mode. Let's just see if this calculator is set to do that. If I find some calculators have the I button, some do not. Let's see. Oh, that one will... did I write the wrong problem? Oh, it's not the problem that I had on my paper, but that would be true for that problem. But I had, what, a 6 minus 4i, and then squared. And notice it is 20 minus 48i. If your calculator says non-real or something, it might need its mode reset. So you might need to go to mode, and I'm in... need to click on A plus BI mode, then you'll for sure be able to do those. So if your calculator has a mode button and you can imaginaries, that will help as well. So you might be able to use that on your calculator, but it's good for you to understand the concept to be able to do it by hand, even if you are using their calculator some. All right, so foiling here, first is 16. Outer is 4i. Inner is a positive 4i. And last times last, because the signs are different, it looks to be a negative I squared. Because it's I squared, that is negative 1. A negative negative 1 makes that a plus 1. So you've got 16 and 1, which is 17. Minus 4i and plus 4i cancel out. And so that's 17. Now, I mentioned this in the early videos. This is actually multiplying by a complex conjugate. They're the same two terms, an I, one with a plus, one with a minus. Anytime you multiply conjugates, you should expect to get a real number. It gets rid of the imaginary. We're going to use that technique in number 20 and 22. So it's kind of a rule for reducing imaginaries that you should never leave an imaginary nor a radical, if that's maybe come up in your review section. You should never have an imaginary or a radical in the denominator. We always rationalize the denominator, which means make it one of these numbers like 17, a nice rational number. No i's, no radicals. So the trick for doing that is you take whatever the denominator is and multiply it by that conjugate. We know that multiplying by a conjugate always makes a rational real number. But you can't do that just for the sake of doing that unless you balance your equation or balance your fraction. So whatever you multiply the denominator by, you have to also multiply the numerator by. So it's like I'm timesing by a form of 1. Do you see that? 6 minus 2i or 6 minus 2i would be 1. So I'm multiplying by a form of 1, but this form of 1 is chosen specifically to make this rational on the bottom. All right, so here we go. The first times first is 36, and we know that outer and inner of a complex conjugate cancels out, so it's the last times last is negative 4i squared, which will change to plus 4 for a total of 40. So a nice rational number in the denominator. Now, not so for the numerator, but that doesn't matter in this case. It is what it is. So the first is 36. The outer is minus 12i. The inner is plus 42i. And the last times last is minus 14i squared. The minus 14i squared will transfer to a positive 14. 36 and 14 is 50. Minus 12i and 42i is 30i, and that's over 40. And then we need to clean that up. We cannot leave one fraction, the real and the imaginary part, together. It says to put it in A plus BI order, so we have to pull those apart as separate fractions. So we have 50 over 40, which I can reduce in a minute, and then we have the 30i over 40. Then reduce those fractions. 50 over 40 is 5/4. 30 over 40 is 3/4, and there's your I, and that's the correct A plus BI form you would leave that. All right, one last example. We're going to repeat this process on number 22, and we're going to multiply the denominator by its conjugate. 9 minus I, so I'll multiply by 9 plus I. Whatever I do to the denominator, I have to do the same thing to the numerator to keep the balance. So it's timesing by a form of 1. And then we just multiply away, a lot of the FOIL method. So I'm going to do the numerator first here. It doesn't really matter, but the first is 81. Outer is 9i. Inner is also 9i. And last times last is positive I squared. We'll clean that up in a minute. Let's go ahead and finish the FOIL method. First times first is 81. Outer is 9i. The inner times inner, notice, is minus 9i. Like conjugates always work out, you get the middle terms drop out. Then the last times last is minus I squared. Then let's clean this up. I squareds are negative ones, so that's negative 1 or plus 1 there. All right, in the numerator I have an 81 minus 1, which is 80, a 9i and 9i, which is 18i. In the denominator, 81 plus 1 is 82. 9i and minus 9i cancel out. Then lastly, we need to pull this apart into A plus BI form. So we have 80 over 82 and 18 over 82 with the I. And then those will reduce. I think the best we can do is divide by 2 here. That'll half into 40 and that'll half into 41. So we've got 40 over 41. And then 18 over 82. I'm wondering if there's anything larger than 2 that'll go into those. I don't think there. We can just half that and make that 9. and half of A again 1, and then I. So that's how we would leave reduced and part our final answer there.